Alright guys, we're going to do a few examples of polynomial operations. Now we've got three binomials being multiplied by each other. So we're going to start with the first two. We're going to simplify this down. The first two, we know that if we're just multiplying two binomials, we can use FOIL or distributing. First, outer, inner, then the last terms. So the first term's 2c times c gives me a 2c squared. Outer, 2c times negative 15 gives me a negative 30c. Inner, 5 and c, positive 5c. And last, 5 times negative 15 gives me a negative 75. All right, then from here I can simplify my like terms. And I know that this trinomial now needs to multiply with this last binomial. All right, so a trinomial times a binomial, again, everything gets multiplied to the terms. So I can start with each term in the trinomial being multiplied by the first term in the binomial. 2c squared times 6c gives me a 12c cubed. Negative 25c times a 6c gives me negative 150c squared. Negative 75 times 6c gives me a negative 450c. All right, now to distribute all of these terms in the trinomial to the second term in the binomial. So I've got 2c squared times negative 22, giving me a negative 44c squared. Negative 25c times negative 22, giving me a positive 550c. And negative 75 times negative 22, giving me a positive 1,650. Last but not least, I'm going to combine my like terms. I've got my c squared, and I've got my c's that are like terms. I'm going to combine them. So my answer is 12c cubed. My c squared's negative 150, and negative 44 will give me a negative 194c squared. And my c's, so negative 450 and a positive 550 will give me a positive 100c. And last but not least, my 1,650. Here we go. All right, let's try this example here. Let's say we've got a very large quantity. This is a large polynomial, and we're subtracting it by 3 times the same smaller polynomial. So let's simplify this down to see what we get. Order of operations here, the first thing that I see is I have to distribute this negative 3 to all of the terms inside the parentheses of this second polynomial. So I'm going to start there. So again, this negative 3 gets distributed to the 2, 55, the negative 93, and the negative 567. So negative 3 times 2 gives me a negative 6x cubed. Negative 3 times 55 gives me a negative 165 x squared. Negative 3 times negative 93 gives me a positive 279 x. And then negative 3 times negative 567 gives me a positive 1,701. Last but not least, we're going to bring together all the like terms. So my x cubes in blue, so I've got 4 minus 6 giving me a negative 2. I've got my greens, the x squareds. When they come together, I get negative 492x squared. I've got my x-like terms, so negative 560 plus 279 gives me a negative 281. And then I've got my constants, the ones without any variables, negative 499 plus 1,701, giving me 1,202. Make sure that your terms are ordered from the largest exponent all the way down. In this example, we're going to use the factor theorem to show that x plus 2 is a factor of 2x cubed plus 3x squared minus 17x minus 30. The factor theorem states that if x minus a is a factor of f of x, then f of a equals 0. So what we're going to do, this is saying, again, that we've got this x minus a. We're trying to figure out if this is the factor of a polynomial. And this would be a factor of the polynomial if we just take the a, plug it in for all of our x values, and our f of x, or our y value, or our output, equals 0. Now again, notice that we've got a negative a here. We got an x minus a here. And then it's saying f of a here, a positive a. This is telling me I'm going to change the sign of whatever this a value is to plug it into f of x. So for instance, if I'm trying to show that x plus 2 is a factor of this polynomial, what I'm going to do is change the sign in here. I'm going to say that x is negative 2, and I'm going to plug negative 2 in for all of our x values. All right, and all I'm going to do is simplify this down and see if I get 0. So we got negative 2 cubed gives me a negative 8. Negative 2 squared gives me a 4. Okay, 2 times negative 8 gives me a negative 16. 3 times 4 is 12. I've got a negative 17 times a negative 2 giving me a positive 34 minus 30. Here I get a negative 4. Here I get a positive 4, 0. So I can say yes, x plus 2, that binomial x plus 2 is a factor of this polynomial using the factor theorem. All right, in this example, we want to see if 2x plus 7 is a factor of this polynomial using the factor theorem. The factor theorem states that when we have x minus a, we can determine if this is a factor if we take a and plug it in to our x values, and our output is 0. Now, does this binomial look like x minus a? Not exactly, because here our x is 1 and here our x is 2. So what we need to do is factor out this 2 so that way we have a 1 as our x. Okay, if I'm dividing by 2 across the board, I get 7 over 2 as my A. Now, we want to pull out if my original factor theorem has a minus A, we need to pull out the opposite to plug A in. Here we have a positive and my A is 7/2, but we're pulling out the opposite of what we see for A. And this negative 7 over 2 is what gets plugged into all of the x values. All right, and then I'm going to simplify this down. So this whole quantity right here turns into a negative 343 over 4. This whole quantity turns into a positive 343 over 4. This turns into a positive 14, and then we've got this negative 14. All of this cancels, all of this cancels, I'm left with 0. So yes, we can say that 2x plus 7 is a factor of this polynomial. Using the factor theorem, we got 0, everything checked out. Last but not least, let's do an example where we're dividing polynomials. Again, this is still very similar to our long division where we're going to divide, multiply, subtract, and bring down. So the first thing we're going to do is ask ourselves, how many times does 3x squared go into 12x cubed? So basically, what times 3x squared will give me 12x cubed? That's what you're asking yourself. And here we can get 4x. Because 4x times 3x squared will give me a 12x cubed. But when we multiply 4x by this first term, we have to multiply 4x by the next term, the second term. So 4x times negative 4 gives me a negative 16x. Just negative 16x, not the x squared. So this lines up with the 48x over here. So negative 16x. What I'm going to do now is subtract everything. This gets canceled, so I'm going to subtract here. This gets canceled, and I'm going to subtract here, and this double negative turns into a positive, so I've got 48 plus 16, giving me 64x. And then I'm going to bring everything else down. And I'm going to repeat this process. So what times 3x squared will give me negative 150x squared? Now I already have the x squared and the x squared matching up, so I'm just asking myself, what times 3 will give me negative 150? And that's going to be negative 50. So negative 50 times 3x squared gives me a negative 150x squared. And then I have to also multiply it by my second term here. So negative 50 times negative 4 gives me a positive 200. Now, I don't have an x. I don't have any variable with this. So positive 200 matches up with the negative 40. Okay, I got to keep everything aligned. And then I bring down the 64x. At this point, there's nothing else that 3x squared can go into with what we have. So this is our remainder. So 4x minus 50 is our answer, but then we've got to put our remainder. Okay, so this is our whole answer right here, 4x minus 50 plus our remainder over our divisor there. So 64x minus 240 over 3x squared minus 4.